Okay guys, we're going to work on problem 58, which is a chapter 6 problem. It does not use the normal distribution. It uses something similar, which is called the StudentT distribution. It's similar, but it's not exactly the same as the normal distribution. The problem reads, the annual earnings in dollars of 35 randomly selected microbiologists are shown in the data table. Use the data to A, find the sample mean, B, find the sample standard deviation, and C, construct a 98% confidence interval for the population mean. Okay, so A and B are very easily done. Here, I need to get Mathematica going here. Okay. So the first thing I am going to do is download the information in my data table. As usual, guys, you've seen this many times already. This is not new to you. Open in Excel. It doesn't really open in Excel. It downloads it. It saves the file, but that's fine. Okay. Directory. Okay, users Douglas, but I know that the file downloaded to my downloads folder. Set directory, users Douglas downloads. Okay. 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 File names. Okay, so this is the file that I just downloaded. Whoops. This is the file that I just downloaded. Data April 3rd, 2020 at 3:47 p.m. .xlsx. Now, really, it's 2:47. Well, now it's 2:49. It was 2:47 when this was downloaded. Pearson uses Eastern time because I believe the company is headquartered in Boston. I think it's Boston. It might be New York City, but I'm pretty sure it's Boston. It's a Boston-based company. So they're using Boston time, which is 1 hour ahead of us. Okay. Let's change that file name to something a little bit more meaningful. Whoops. Let's see. Data for 3/2020 3:47 p.m. .xlsx, and I'm going to simply call it problem 58 .xlsx. Shift enter. Okay. File names, table form. Okay, I can see the problem 58 is right there. It used to be called something different, but I renamed it to problem 58. Okay, my data is equal to import problem 58.xlsx data. We're going to flatten that like we usually do. My data is equal to flatten my data. Okay. There's no need to sort it. We don't have to worry about that for this type of problem. So the mean is the mean of my data. And that is 71,989.4. 71,989.4. The sample standard deviation is easy to figure out. standard deviation, my data, and round it to 2 decimal places. So that's 15,396. Actually, I think that's going to be 15,397.00 if we round it to 2 decimal places. Okay, construct a 98% confidence interval for the population mean. Now, it's important, you need to look at this part very, very carefully. It says find the sample standard deviation. So the population standard deviation is not given to you. Okay? The sample standard deviation is given to you. Because of that, you cannot use the regular normal distribution. You have to use a modified form of the normal distribution, which is called the StudentT distribution. All right. So remember, guys, 98%, you're not going to use that figure directly. 100% minus 98% is 2%. Half of 2% is 1%. We're going to add that to the 98% to get 99%. So my t-score, this time it's called a t-score, not a z-score, is equal to inverse CDF, StudentT distribution. The StudentT distribution is one parameter, and that parameter is the number of scores that you have minus 1. So the length of my data is 35, so this parameter, which is called the degrees of freedom, is going to be 34. And yes, I know it's 98%, but we're going to enter 0.99. Okay? That value is about 2.44. So 98% of the area under that curve falls between negative 2.44 and positive 2.44. Okay? Now the confidence interval is very easy to figure out. So confidence interval is equal to mean minus standard deviation times t-score divided by the square root of 35, mean plus the standard deviation times the t-score divided by the square root of 35, and that's it. And according to Pearson's instructions, I'm supposed to round to the nearest integer as needed. So let's see, confidence interval, round, table form. Okay, so I am 98% confident that the true population mean for the annual earnings of all microbiologists is somewhere between $65,636 a year and $78,343 a year. Let's see if that's correct. 65,636, 78,343. That should be correct. Let's see what Pearson says. Terrific. Okay. I hope this is helpful. Please watch these videos. I do work hard to make these videos and upload them to YouTube for you to learn from. So please look at my videos, watch them, and hopefully they will help you to succeed in the course. Okay? Thank you, and have a great day.